Hi, so this is a video that is an accompaniment to the Medium article that I wrote regarding the sign language practice app. So I just want to go over in this video sort of how I coded it in terms of, going through different iterations, gathering data, trading and testing a model, and then deploying it through Flask. So I'd like to first off go through the code. So sort of where I started. A couple of important libraries to point out is CV2, that's going to be OpenCV, that's used for a lot of computer vision things. And then MediaPipe as well. And MediaPipe is really awesome. There's a lot of things you can do with it. You can do image segmentation, you can do sort of tracking, object tracking through different frames. But for our purposes, we're actually going to use it to track our hands in particular. And so the first thing I want to just put attention to are these helper functions that I have here. So this is going to detect the hands themselves. And then for the second one, drawing landmarks, a landmark is actually just going to be sort of a point on your hand. There's 21 different landmarks. The 0 index one is sort of the bottom of the palm, or the wrist, I'll call it. So there's the wrist plus 20, and you can sort of think it as different joints on the fingers as well as parts of the palm. So that's going to draw onto our webcam those landmarks as well as the lines that connect them. And then I just have another function for when I collect the images themselves, I want to sort of standardize them. So I'm going to crop that to just where the hand is. I'm going to resize it down to 128 by 128 pixels because any neural net input, you need to have the same dimensions across all data points. And then I'm going to grayscale it. You also will have to standardize it from 0 to 55 to 0 to 1. I do like to look at the images, so I don't want to do this because then it's going to just be an image of black. So I just want to get into using the code. So I'm going to stop my video so I can just look at the screen. So what this code basically does is going to basically go through and find, our resolution, so the width and height. My integrated webcam is only 480p, while my external webcam is 1080p. So you'll find that I have a nice variation in data that I've collected, but it's going to be very different depending. So we need variables for that. And then so what this does is I'll press, save the data with space, and I can also label it with whatever character I press. So these ranges are for the letter keys. And then I'm going to create a static bounding box at first. I'll show you what I mean. So this will load up my external cam. This is the bounding box right here. It's a little hard when it's mirrored. But basically what I do is I'd say, I want D, so D will show up. I'll do this, and then maybe I'll press space, I'll save it. So I'll exit that with escape. That's just what this little break is going to be for, this 27. And so this will say, okay, we wrote a image file with D, and this is just sort of a timestamp. I also played around with the rotating image. This is just like an L that I took. Not so great because it gives these little black areas of the picture. So what I ended up doing is just going to rotate my hand instead. And so I began with a CNN, which is sort of the, I don't want to say default, but basically default for any sort of image modeling. So what I did with this is basically I wanted to put things onto the image. So here we have the landmarks. So these dots are the actual landmarks. The blue box is going to be a bounding box that scales with the max width and height of the hand itself. And then the green box is going to be a square box for that, with a little more padding than the blue box. So I can, go in and out, and that's going to change. And I'm actually going to use the green box in terms of cropping. So I do that. I collect all my data. I basically put that in from the hand images into, training and testing data. So I'll do that. I only grabbed the letters in Hello World as well as B, because B is pretty different than the others. And so I'm splitting it into training and testing. I'm just calling it validation here because testing is really going to be what I do on the webcam. Afterwards, 80-20, but neural nets also let you split it further. This is just a test of the label encoder to make sure that it's encoding correctly, because for neural nets, you need to pass the labels in as numbers instead of strings. This is the CNN itself. Basically, I have two convolutions going. This 3x3 kernel, you can imagine, 128 by 128 grid. There's going to be, when passing by, it's going to do it in 3x3s. And then what the pooling does is you're going to have 2x2 sort of summaries. I guess you take the max value of those 2x2s and then pass that smaller grid onto the next convolution. And I do max again. This flatten is basically because there's 3 channels. It's RGB for the colors. Even though I grade scaled it, there's still 3 channels, unfortunately. They're all the same value because it's gray. I actually ended up getting rid, or trying to get rid of it later on, but that's not going to work. Doesn't really matter. I trained on 8 epochs, very, very small, but again, there's only 128 data points per letter at this point. And so I didn't want to overfit too much, but even here I got, massive accuracy where it's nearly 100%. Even on the evaluation of the validation data, it's also nearly 100%. So we can test that model here. So waiting for that, basically, if I hold up a W, O, R, L, and I nearly did, or I did do the wrong letter, so that's an E, by the way. Okay, so that's fine and dandy. But I realized, MediaPipe actually outputs the coordinates of the different points on your hands, which is a lot more useful and precise than the images. So originally I tried doing Euclidean distance to different points, but we're going to skip that and go to where I actually did it using an X and Y split. Basically, I did distance from the wrist. So again, the first landmark itself. And then I multiplied by sort of like a scaling factor. So the width and height is going to incorporate the resolution of the screen, as well as the X and Y are going to be the lengths of the box, sort of the cropping box, because you can go in or out from the screen in sort of the Z axis. And we want to make sure that the values are the same, regardless of how far you are from the screen. And then I lop off the wrist because it's going to be 0 distance regardless. So not very useful. So here, basically you'll see, the landmarks, the box, and I can put in different points. If I press a particular letter, it will take, a snap of that data and throw it into a data frame. And this is what that data frame looks like. You're basically going to have an X and Y for each of the 20 landmarks, plus I just put in a label, toss that into a CSV. So here is my folder. This is the CSV where I saved it. This is the number of labels. For J and Z, I didn't know if I was going to use them, so I got less labels. If I wanted to have more accuracy, I would, take more images. And by images, I went inwards, outwards from the camera. I tilted my hand. So I made sure to have a lot of variation. And so I did another neural net. So stratifying on the letters. This time I have all the letters, which is nice. This is just a normal neural net. I don't need any convolutions because it's not image. I did 100 epochs. But you'll see, the accuracy goes up pretty high once it hits a certain amount of epochs. Yep, there it goes. So perhaps I should run it for a few more epochs than this, but in the end, I ended up not going with this. Yeah, if I had 200 epochs, I actually go higher and higher. I ended up using just a normal classifier. It would be, a lot easier than, using a neural net in terms of storing the model. And there's no reason not to. I just picked a random forest classifier. So on this one, I train it and I get, 100% accuracy on training. Could be overfit, but I also get 99% validation or test score. So it seems like a pretty good model. And then to test this, here's another chunk of code. Basically what I'm doing is, for each, third of a second, basically, I don't want to do it for every frame. Basically, ripping the image, I'm doing a prediction. I'm finding, which one has the highest probability. And then, so if the probability is greater than a certain amount, so 80%, then that's the predicted letter. And then I'll add that to whatever word I'm trying to spell. So let me give you an example. So this is my smaller webcam, so it's going to be, shoddier in terms of resolution, but, I can try saying hello at least. So that's H-E-L. You have to slide it in sign language to get doubles. So there's another O, do hello world. I think the R is a little shoddy. Yeah. Hello world. So there you go. And then it sort of spits it out. But what I wanted to do, and what I'm getting to with the app itself, is sort of practice, right? So what I wanted to do is sort of give a person a word and have them spell it in sign language. So I use the English words package for this, basically ripped out everything that's, too tiny of a word, so 3 or less, or greater than 10, too long. I also took anything that has Z out, because Z is very hard to predict on this model. And so this code I put into the next notebook that I'm going to show. So we'll just go right to that notebook. This is the sign app notebook. I also have it up in Sublime because it's really the Python file that's used in our Flask application. But it's easier to go through with these little chunks. So I imported, all the necessary packages, libraries. Flask, you need to import Flask, rendering the template, response, and request. And I created a few global variables here. I also imported the model. So for building a Flask app, you need to, create an instance of Flask. Flask is sort of a framework in Python, and it interacts with the front end. So the front end being an HTML file, so you're going to need some sort of place to put that. So this is what the template folder is. I put the HTML in template. And so what I did here, because I have 2 webcams technically hooked up, I wanted to find the highest webcam index, because the video capture function uses the index. And so assuming that my external webcam has a higher index, I want that to be the one used when it's plugged in. It's basically the same. I'm instantiating a bunch of variables that I'll get to. Here are my helper functions. They look pretty similar, right? And so now I have 4 different modes, and I will sort of explain them using the site that I have that's spun up with Flask. And so I have 4 different modes. I have an easy mode, I have a medium mode, I have a hard mode, and I have a free mode. Easy mode, you're going to see that I'm going to draw in letters. This is sort of the helper letter image. I grab them from Wikimedia. I store them in this easy mode letters folder. They just sort of look like this, just as sort of like a help. This is what you need to do. And so that's easy mode. Medium mode is basically the same thing, except without that showing up on the screen. Basically, if you get the letter right within, 70% accuracy, or some of the harder letters, I gave a little more leeway, 60% accuracy, and then it's going to add it on. Here, it's looking for the double letters. So this little location thing is basically saying if you slide your hand over, more than 10% of the screen, then it'll detect that that's sort of your double letter. And then for hard mode, what we do is we actually have a counter for wrong. And so what wrong does, basically, if you get it wrong a certain amount of times, let's say the letter is A, but you say C by accident, and then maybe E, and it counts number of frames. So it could be, 2 frames of C and 3 frames of E. Once you get to that, it's going to start the letter over. So that's hard mode. And then free mode, you can basically spell whatever you want. It's going to pop up in yellow letters because I was using white letters for putting out the word, and then it'll lay over in green when you get the letter correct, and then move to the next letter, which I'll show. By free mode, basically, you can build whatever word you want. And then there's this little eraser. Basically, if there's no hand detected in frame, it'll erase the word after a certain amount of time. So this is for the framework itself. Basically, the different modes are going to be used here, and this connects to the HTML file. I'm just going to show one last part of it before going to the HTML file. So for a Flask file, you always need app.route, and then you'll have whatever, slash whatever. This is sort of the standard. And then so this, you need to define a function underneath, and then it'll return whatever. So for Flask render template, it'll render the template that you put in. And this index HTML, I also have in Sublime. Basically, all it says, I welcome to sign language practice, choose your mode. I describe the modes. And then here, there's going to be buttons. And this is sort of the post action where a user can sort of submit an action to the back end. And that's going to be this requests here. And so I can actually get rid of this. Here it's going to be, if you choose the easy button, for example, it's going to set this easy sort of indicator to 1. It's going to choose a new word for you and erase, if you had any letters correct, it's going to erase that. And it's going to be the same for everything. Obviously, except for freestyle, because you don't need a word. And then if you're not, clicking anything, you're just going to get the index back. And so these are the buttons that interact with this code. And so I'll show you that now. So I'm going to pull up the Anaconda prompt here. I have Anaconda Navigator as well, already running the Jupyter Notebooks. If you don't, what you can do is you can just type Jupyter Notebook and execute that, and it'll open up Jupyter Notebook. It'll put on port 8888. But what I'm going to do now is I'm going to just, let's see, ideas projects, I believe CV2. Oops. And it should be sign language app. Yes. So take a look at what's in here. Okay, so we have our Jupyter Notebook. We have the Python script. And so to get from Jupyter Notebook to Python, if you're not building an IDE, you do an NB convert. So Jupyter NB convert to script, and then you're going to put in your sign app. So that, and just run that. For Flask, so I'm using Windows right now. I believe in Linux, you don't have to use a set command, but we're going to set this Flask app variable equal to sign app.py. If you call your Python file app, you don't need to do this step, but that's going to set it so that the Flask knows to look for this particular Python file. And then we're going to say Flask, I'm sorry, in Windows, you'll need to prefix that with Python -m or -m, Flask run. That's going to run Flask. And so what we can do now is go back here, and it's going to pop it up in our sort of local hosts here. And if we refresh, we get our page. So we have the word down here. It just picked Trapes. If I click the button again, it'll come up with a new word, anagram. So, you know, I have A and then N, and some words are a little more finicky than others, but, you know, I'll do A like it shows, G, then R. I think R is one of the finickier letters. And again, I just have to train the model a little bit more or use more, whatchamacallit, data points. But basically that's how it works. R and U are a little finicky. They're the Argos. So A and then, you know, M. And once you get the letter, it'll freeze for half a second and come up with a new one. Medium, again, there's no help here. You just kind of go for it if you know the letters. So WAM, WH, A, M, and so on and so on. Hard, again, so T, thistle, so TH, maybe I don't know I, maybe I guess like E, crud, you know, C, it starts over. And then freestyle, you can do whatever you want. So here you can say, you know, hello world, H-E-L, you slide the L over, O, W, O, and again, the R is going to be a little tough. It'll probably predict the U, L, and then a D is like that, you know, hello world. And then you move your hands back and then it clears. So that's basically it. You can keep practicing to your heart's content until you get it correct. Again, easy mode, you get help, and that's basically it. And if you just want to shut it down, you can do a Control-C here, and that'll shut it down. And I wasn't able to put it onto Heroku. I do have a Heroku, oops. I do have a Heroku page for it. I believe it's sign language practice. Unfortunately, Heroku uses its own servers for detecting cameras. So I'm not going to be able to detect, you know, the user's camera. So you'll have to run Flask if you'd like to practice. But yeah, that's the code. So thank you for watching. And I hope this gives you some ideas for your own codes.